Hey guys, welcome back. Today is day 20 of this 30 days Leetcode challenge, and today's question is about constructing binary search tree from Preorder Traversal. So we are given an array of Preorder Traversal, and we have to construct a binary search tree. Now, pre they have defined what preorder actually means. So in preorder traversal, we first display the node, and then we traverse its left subtree and the right subtree. So let's say if this is the array that is given to us. So the left subtree in this case, yeah, the root will be the first node that will be traversed, and all the elements that are less than the root will go in the left subtree, and all the elements that are greater than the root will go in the right subtree. So that is how we can construct the binary search tree. So what we'll do is when we are creating the tree node for a particular node, uh, will iterate through the input array and fill the value of whatever I is pointing to, uh, and that will be the tree node. Now for creating the left subtree, we'll use a recursive function, and we'll say that for the root node, the minimum limit uh, will will be whatever is the integer minimum value, and the maximum limit will be the maximum value. But when we go for the left subtree, the maximum value in that case will become the value of the node from which the traversing is happening. So in this case, the maximum value in the left subtree can be 8. Now, if you look at the node 5, the maximum value in the left subtree can go up to 5. So if we find a node that is greater than 5, so in that case, we'll just return a null subtree. So that is how we can perform this. That is how we can write this code. So let's say I'll just create another function which says create tree, and I'll pass in the pre-order array and an iterator I which will start from 0. So that will be passed, and I'll in this case the return type will be tree node, and I'll be creating a tree. So this is the pre-order array and an iterator I that is taken, and also will pass in the limits for applicable for a particular node. So the minimum limit will be the integer's minimum value, and the maximum limit will be the maximum value for the root. So this will be the min value, and that will be the max value. Now our base case would be that if our I became more than the length of the array, or the element at the index I is less than the min value, or it is more than the min value. Basically, if the element at I is out of bounds, then we'll just return null in that case. And for others, what we'll do is we'll create a tree node, and whatever is the value that we are iterating to, whatever I is pointing to, can be used. And for the left subtree, what we'll do is call recursively create tree, and in this case we'll have to point to the next I, but we cannot pass an I in this case, because uh, if we pass I in that case, and if the left subtree ends up getting created, then the value of I, the updated value of I, won't be reflected in this recursive call. So ideally we should be storing this as a global or maybe static variable. So I'll remove this from here, and just create it outside, and it won't be part of the recursive function. Now for the left subtree, the min value will stay the same, but the max value will become whatever value was updated whatever value was stored for that particular node, and for the right node it will be something similar, but in this case the min value will become the node's value, and the max value will stay the same, and we'll just return whatever node we created. So yeah, this should work. So let's see, it became greater than or equal to, this should be greater than equal to, yeah, yeah, that's what, because even I becoming equal to the length is not a good, not valid. So yeah, our solution works. So let me submit this and check. Yeah, it has been accepted and all the test cases have passed. Yeah, so our solution has been accepted. So thank you guys. If you like this video, give it a thumbs up, and do subscribe to my channel to be notified about the day 21 problem.